Welcome and study with Tanzania Institute of Education.
Hello, welcome to our chemistry class. My name is Madam Jennifer Kazlege. I'll be with you discussing Form 3 topic known as volumetric analysis. But today we're going to concentrate only on the calculations, or we call it volumetric analysis calculation. Then before we go to see the example of calculations, let us see or remind ourselves about the previous discussion. We were discussing about titration, and we said titration is a process of adding acid to a base slowly until we reach the end point. But also we discussed about the choice of indicator, whereby it depends on the strength of the acid and base. But also we saw the table of results. What is contained within a table of results? So after completing your experiment, you need to record the data. So the data must be recorded within the table. And how do we record the data? We saw the table of results in the previous discussion, whereby today we're going to see the actual example on how we can go about calculating the concentration of unknown. But also, let us remind ourselves, what is the function of volumetric analysis in different aspects? We are using volumetric analysis to determine the relative atomic mass of an element. We are using volumetric analysis to determine the concentration, whether it is mass concentration or molar concentration. But also we are using volumetric analysis to calculate the percentage purity, the amount of purity present within a given compound, but also the percentage impurity. Not only that, we are using volumetric analysis to calculate the water of crystallization present within a given salt. So today we are going to see an example on how we use volumetric analysis to calculate the relative atomic mass of a given element in a given compound. So, example. Make a solution of metal carbonate X2CO3 by dissolving 2.12 gram in water to make 250 cubic centimeter of solution. 25 cubic centimeter of a metal carbonate solution, metal carbonate solution was titrated with 0.25 molar hydrochloric acid by methyl orange, by using methyl orange as an indicator. Then the following results were obtained. were obtained. So it was experiment between metal carbonate and the hydrochloric acid. It was experiment between metal carbonate and hydrochloric acid. What was it? Make a solution of metal carbonate. So it was a solution of metal carbonate. Metal carbonate, we don't know what was this metal. Whether it may be sodium, it may be potassium, it may be calcium, whatever. By dissolving 2.12 gram in water, when they dissolved the 2.12 gram in water, they make a solution of about 250 cubic centimeter of a solution. Then they took, out of this, they took only 25 cubic centimeter of a metal carbonate solution, was titrated. They titrated it with 0.25 m hydrochloric acid. So 0.25 molar of hydrochloric acid. This shows that this is a known concentration. So hydrochloric acid was a standard solution. Then using methyl orange as the indicator, after that they obtained a table of results. And then how does the table of results look like? This is the table of result. After titration, table of result were obtained. Within our table of result, as I explained, we must have 3 experiments. So here it is experiment, and then we must have a pilot as a starting point, the direction where we want to go. And then we conduct experiment 1, we go for experiment 2, and then experiment 3. We need to record all the experiment. So I said we must have a final volume. This one, you are reading it in the bullet in cubic centimeter. We must have initial volume. Also in cubic centimeter, we must have the volume used. Volume used, or we call it title volume. Volume used. Also it must be in cubic centimeter. Then the data was recorded. The initial volume before experiment, it started from 0, 0. The table must be filled with 2 decimal places. And then titration went until when they reached 17.00, there was a color change. That makes the end of the experiment. And then first experiment also, they filled the bullet up to 50, which is 0, 0. They titrated it until when the end point reached, it was 16.1. And then experiment number 2, the initial volume was 16.1. The titration proceeded until when the end point reached, it was 32.00. And then they filled the bullet again at 30.00. That was the initial. And then the last experiment, the final volume was 46.1. This is a table of results. Then how can I get the volume of acid used? How can I get the volume used? Then to get the volume used, you must subtract final minus initial. You must subtract final minus initial. Therefore, how do we get? This is 0 minus 0, it is 0. This is also 0. 7 minus 0, it is 7, and this is 1. So the pilot, the final volume or the end point was reached when the volume used to reach the neutralization point or the neutral point was 17.00. Then come here, it is 0, this is 1, 6, and this is 1. So 16.1. This is also 0 minus 0, it is 0. Okay, ball 1, put it here, to be 10, it is 9. What is this? We remain with 1. Ball 1, put here, it is 11, so it is 5. We remain with 2, also this is 1. So, and this it is 0. 1 minus 0, it is 1. 6 minus 0, it is 6. This is also 1. So the volume used for every experiment is already recorded. Now we have the volume for the pilot, the volume used for the first experiment, for the second experiment, and this is for third experiment. Now we need to know the volume of acid used. We need to know the volume of acid used. After experiment, how do we get it? We must add the volume for experiment 1, experiment 2, experiment 3. The pilot is not included. Why we are not including the pilot? A pilot is like you want to go somewhere, but you don't know how to reach there. You may use a map, or you can use the direction that if I want to reach somewhere, I must pass this way. So by passing this way, I'll be reaching where I want to go. Same applied to pilot. It's directing you the end point. So from the pilot, you are approximating that between this volume, I'll be reaching the end point. That is when you start your experiment. Now, how do you calculate the volume of acid used? We go for questions. This is the questions. Number 1 is asking, find the average volume. Find the average volume. Average volume used. So how do we go about it? Is solution. Average volume, that is a volume used. Average, the average volume is obtained by taking title 1, that is volume used for experiment 1, for experiment 2, volume used for experiment 3 divided by 3. That is how do we do calculate the average volume. Then let's see, record or take the data from our table. What is the total volume for experiment 1, total volume for experiment 2, total volume for experiment 3. You may try even, take a piece of paper, try to calculate. Therefore, volume used, average volume, is equal to what is for experiment 1, it is 16.10. For experiment 2, it is 15.9 plus 15.9. For experiment 3, it is 16.1. 16.1. So the average you must divide by 3, and the answer will be 16.03 cubic centimeter. So now we have the volume used. What is the volume of this? This is the volume of acid used. It is the volume of acid used. Why? Because the acid was filled in the burette. After finding the average volume, we go for question number 2. Roman 2, it is asking, write down the balanced chemical equation. Write down balanced chemical equation. Chemical equation. Chemical equation. So you must write what is happening between metal carbonate and hydrochloric acid. So we'll go for solution as well. What is happening? It is metal carbonate. This one we are reacting with the hydrochloric acid. And then what will be the product? The product will be metal chloride plus water plus carbon dioxide gas. This is metal chloride and the water and the carbon dioxide gas. Make sure you write the state symbols. Make sure you write the state symbols. Make sure you write the state symbols. Then now we have a balanced equation, which I'm not sure if it is balanced. So let us balance it. We have 2x, there is 1x, so x is not balanced. We have 1 carbon, we have 1 carbon, so carbon is balanced. We have 3 oxygen, there is 1 oxygen plus 2 makes it 3. There is 1 hydrogen, there is 2 hydrogen. Hydrogen also is not balanced. What about chlorine? 1 chlorine, there is 1 chlorine. So chlorine is balanced. We need to balance x. What if I had 2 here? To make chlorine to be 2, if I had 2 here, I'll make chlorine to be 2. So what about x? There's 2x, 2x, 2 hydrogen, 2 hydrogen, 3 oxygen, 3 oxygen, 1 carbon, 1 carbon, 2 chlorine, 2 chlorine. Now the equation is well balanced. For Question number 3, or Roman 3. What is it required? It requires you to calculate the molarity. It requires you to find the molarity of base. Number 3, calculate molarity of base. Class, do you remember the molar ratio formula we derived the last time, or in the previous discussion? I guess we do remember. What was it? We were using molarity of acid, volume of acid, over number of moles of acid is equal to molarity of base, volume of base, over number of moles of base. What do we have in our reaction? What do we have in the question? So it was given from the question that molarity of acid was about, from the question it was given as 0.25 m. Okay, and the volume of base, they took only 25. So volume of base, it was only 25 cubic centimeters. The volume of base is obtained from the average volume used. Therefore, what is it? Volume of acid obtained was 16.03 cubic centimeter. What do we need again? We need to know molarity of base. This is also required. We don't have it. Number of moles of acid and number of moles of base, these are going to be obtained from the balanced chemical equation. Where do we get it? I said it from the coefficient number of an acid and base. So here for a base there is 1, here for acid there is 2. So number of moles of acid is 1, number of moles of acid is 2, and number of moles of base is 1. So number of moles of base is 1, number of moles of acid it is 2. 1 for base, 2 for acid. Now we have all the components except one, that is molarity of base. Make subjective from the molar ratio formula. Make subjective from the molar ratio formula. Make subjective from the molar ratio formula. So MB, if you cross multiplication, MB will be equal to MA VA times number of moles of base, divide by volume of base, number of moles of acid. What are these? This is 0.25. Define it. It is moles per cubic decimeter times volume of acid. It is 16.03 cubic centimeter times the number of moles of base, it is 1. So times 1. Divide by volume of base, those 25 cubic centimeter times the number of moles of acid, it is 2. So this and this will cancel out, and the unity will be moles per cubic decimeter. What will be the answer? It is 0.080 molar. So molarity of base, therefore molarity of base is equal to 0.080 m. Now the next is find the molar mass of metal carbonate. Find the molar mass of metal carbonate. We have the molarity. We need to find the molar mass. You cannot get the molar mass if you don't have a concentration. So if you recall back to the question, you are going to read that it was how much dissolved in 250 cubic centimeter. It was 2.12 gram of metal carbonate were dissolved into 250 cubic centimeter. Therefore, mass of metal carbonate were 2.12 gram What was the volume? It was how much? 250 cubic centimeter. Convert it into the cubic decimeter. If you convert, it will be 0.25 cubic decimeter. Why do we need this? We need to find the concentration of metal carbonate. Therefore, concentration will be equal to mass given over the volume, which equals to 2.12 gram over 0.25 cubic decimeter. Use your calculator right now. Try to compute what is the answer. Try to compute what is the answer. I guess now you have the answer. For me, the answer will be 8.80.48 gram per cubic decimeter. Now, we have the concentration of metal carbonate. Now, we have the molarity. What are we looking? We are looking for the molar mass of metal carbonate. How do we calculate? We know that from molarity equal to concentration in gram per cubic decimeter divided by the molar mass. We don't have the molar mass, so make subject by cross multiplication. Therefore, molar mass will be equal to concentration in cubic grams per cubic decimeter over molarity. So now you have everything. What you're supposed to do is to plug the number. You have everything. What you're supposed to do is to plug the number. Then what is next? So molar mass is equal to concentration. It was 80.480 gram per cubic decimeter. Molarity was 0.08 moles per cubic decimeter. Here, if you compute very well in your calculator, you're going to get the answer, which will be 106 gram per mole. So the molar mass of X2 carbonate equals to 106 grams per mole. Then what next? The other question is requires you, number 5, you are supposed to find the relative atomic mass of X and the name X. Relative atomic mass of X. Atomic mass. What is this? You must take X2 carbonate, add, when you add, you must get 160 grams per mole. So it will be 2, if it is coefficient, the subscript, it has to be coefficient, 2x plus molar mass of carbon 12 plus molar mass of oxygen is 16. How many atoms are there? There are 3. The total makes 106. If you go very well, x plus what it is, 48 plus 12 makes 60. You get 106. Then 2x will be equal to 106 minus 60. So x is equal to 46. 2x is equal to 46. 2x equals to 46. By 2, x makes 23. So the last question is name element x. Since it has got a relative atomic mass of 23, in the periodic table it is sodium with the atomic mass of 23. So X is sodium atom. That is how you are supposed to compete. That is how you are supposed to do the question given in titration process. Starting from filling the table, finding the volume used, then after that you have to know how to find the average volume. You have to use the molar ratio formula to obtain the molar mass. You have to use the concept of molarity with the concentration as well as with the molar mass so that you can obtain what is required. Before I finish, I'll give you a simple question. Try this. Try this exercise. 25 cubic centimeter of sodium hydroxide. Sodium hydroxide was titrated with 0.1 m of hydrochloric acid. The following results were obtained. So this is the result obtained when sodium hydroxide was titrated against the hydrochloric acid. So we have the final volume in cubic centimeter. We have initial volume in cubic centimeter. We have the volume used. We have the volume used. So make sure you draw it in a tabular form. This is the experiment. It is pilot, experiment 1, experiment 2, and the last it is experiment 3. So you have to fill the data given. It was 0.00, 0.00, 20.25, and 0.00. Here it reached 20.55, and here it reached 20. They went until to 40.75. Here it was 20.25, and here it was 21.05. Question is, calculate the concentration of hydrochloric acid in 1 moles per cubic decimeter, 2 gram per cubic decimeter. Try this. Thank you very much for listening. I hope you have enjoyed our calculations. I hope now the concept of molarity, the concept of titration on how to tackle the experiment to correct the data and use the data to respond to different questions is well cleared. I wish you all the best. Thanks for listening. My name is Madam Jennifer Kaizilege. Bye.